Hi, everybody. Thanks for coming to my talk at Percona Live Online 2021. I'm going to be talking to you about optimizing and troubleshooting MongoDB through PMM. So my name is Mike Grayson, and I'm a MongoDB database engineer here at Percona. I've been working with MongoDB since 2014, so about 7 years. I'm married with 4 kids and in Rochester, New York in the United States. You can find me on Twitter and LinkedIn at the addresses that are listed. So what do we want to talk about today? I want to talk about what is PMM, just to set the stage so that everyone has at least a basic understanding of what PMM is. If you're not familiar, it's a Percona Monitoring and Management tool, and how to connect PMM to MongoDB. And then we're going to get right into demo time. So what is PMM? As I mentioned, it's Percona's monitoring and management tool. It's an open source database monitoring solution. It can help you reduce complexity, optimize your performance, improve the security of your databases, no matter where they're located or deployed, whether that be cloud or on-premise or in containers. So not only does PMM monitor MongoDB, like we're going to talk about today, it also can monitor the community and enterprise versions of MySQL, MariaDB, PostgreSQL, and ProxySQL. It uses a client-server architecture, which we're going to demonstrate next. It also requires a PMM client or a PMM agent on each host, with the exception being for RDS. That's AWS's relational database service. And then since version 2.12 of PMM, we're using Victoria metrics instead of Prometheus for our metrics ingestion. And that was due to some enhanced functionality that we got from Victoria metrics over Prometheus. And the current version, as of this recording, is 2.16 for PMM. So, as mentioned, here is the PMM architecture. So, on the far left, we see the database that we're monitoring, and we see sitting right next to it is that PMM client. PMM client has basically 2 commands that you can use with it: the PMM agent command and the PMM admin command. The PMM admin command is how it kind of gets configured with the PMM server, and the PMM agent is how it gets, how it gets some of the data to it. You can see there's some exporters as well. In this case, we'll be using the MongoDB exporter. These export data from your databases into the Victoria metrics agent. You see that's either pushed or pulled from the PMM server by Victoria metrics itself. Then we have Nginx as our web front end, backed by Grafana, which writes to our query analytics app, which has a ClickHouse database in it. And then additional metrics are stored in a PostgreSQL database. We'll see a little bit more of that PostgreSQL database during our demo. So next, I just want to kind of quickly set the stage for how you connect MongoDB to PMM. There's 2 prerequisites for connecting to MongoDB from PMM. You need to create a user with appropriate roles to be able to log in, so that PMM can log in. You need to enable profiling so that both MongoDB and the PMM agent will be able to capture slow queries. Then finally, we have our PMM admin command, which is what we'll run to be able to add MongoDB to PMM. You would, if you had a replica set or a sharded cluster, you'd want to run this command on all different nodes, all your different nodes. You'll pass the username. You can optionally pass the password or leave it off to be prompted for the password. You'll provide a service name. This is how your MongoDB instance will be displayed in PMM. So you want to make this name noteworthy. You'll also want to put a host name. You want to make sure that this host name is routable by PMM. For example, if they're in different AZs or anything like that, you'll want to use something that PMM is able to route to this host. And then finally, the MongoDB port as well. So with that, it is demo time. So I'm going to take you on a tour of PMM and show you kind of how you can optimize and troubleshoot your MongoDB deployment through it. So let's move over to PMM. All right, so the first thing we see here is the kind of the splash page for our initial PMM after we've logged in. We can see some dashboards we've visited recently, how many nodes we're monitoring, and then how many database services we're monitoring. Security checks, of which we've got a failure, which we'll dig into soon. The current version of PMM that we're on, and then this also does a check to see if we're eligible to upgrade our version of PMM. At this time, we're on the latest, which is 2.16. Then we have a high-level overview of our environment. Here we can see holistically from an aggregated standpoint how all of our instances are doing. And then we can kind of drill down to specific hosts and see how they're doing. You see we have one for the PMM server itself, and then this one for a database server, which I have not yet configured to collect OS level metrics. This is why you only see the database metrics. We see that there as well. And then another host, which I had configured for an earlier ish thing. So going back up to our failed security checks, if we click on where we see the number 1, we can drill into our security check. Here we'll see that we have one failed check, excuse me, for MongoDB authentication being disabled. So not only does it tell us that it's disabled, it also includes a link to the documentation on how to fix that. While likely no one is, hopefully I should say, no one is running production MongoDB without authentication anymore after all the breaches that we've seen. Be helpful, for example, if we need to turn off authentication temporarily to run any sort of maintenance. This can help to make sure you don't accidentally forget to turn it on. There's 2 MongoDB security checks at this time. The other checks to make sure you're on the latest minor version of whatever version of MongoDB you're running. In this case, I'm running 4.4.5, which is the latest version in the 4.4 family. So next, we're going to take a look at query analytics. So this is where we could find our slow queries for MongoDB or other databases. One thing you'll notice is that you see MongoDB type queries here at the top, and then some more SQL-based queries. These SQL-based queries are from the PostgreSQL database that's in the PMM server. If you want to filter those out, there's multiple ways by either node type, service type, username if there's a specific Mongo user that's connecting to just Mongo, your service name, your node name, or the database. In this case, I'll just do service type since that's the easiest differentiator here. And now you can see that I only have MongoDB queries. So we can see the different queries and then how much how much load they cause on the system, and then how many query per second they were. So we'll go with this insert one first. You can see not even a tenth of a query per second on average. Query time was still not that much. And the response was also not that much, again, because this is a small database. And then I'm not doing terribly much on it at this time. And you can see we did an insert here of just a field with an underscore ID. So nothing. And then we can also look at explain plans for our queries. This particular query, this update query, is an internal MongoDB query, so it's not something we would traditionally performance tune or anything like that. But it is helpful to kind of see what an explain plan can look like. You see the different stages and what the query was doing. You can see in this case, it was wasn't really returning anything because there wasn't really anything to update. But this can be very helpful. For example, if you see something where you're doing collection scans, or if you have an aggregation, you can kind of go through the different stages and see where it might be slow. So this is very powerful when you're looking at your slow queries, to be able to kind of see where they're slow and what they're doing, how often they're running, and how much of the load a particular query is generating. You can see the load's pretty low on the system because my most load-based query is running these explain plans. So that's one way you can optimize, because you can definitely find your slow performing queries. So find out which queries are great candidates for additional indexes. So next, we're going to go into the MongoDB instances overview dashboard. So this dashboard kind of gives you a high level of a particular instance. In this case, I'm going to do it for my one node. I can see how my connections are trending over time, my uptime, how much memory I'm using, or how much mapped memory I'm using. That's usually going to be none if you're using WiredTiger, as I am. How my latency overall is. So connection detail. This will be pretty boring for my specific instance, but if you figure you're running an application or applications that are all using the same database, this can be helpful to find out which database has the most connections. Or if you have other pieces of software like Kafka, for example, connecting, kind of see who has the most connections in case there's any kind of connection storms or anything like that. Latency detail is another one, probably more powerful or more helpful than the connection sometimes, depending on your issue. You can see who is having the most read latent queries. So this can potentially say Kafka is pulling from your data, but it's using a very inefficient query to do so. This could point that out. And if you go into the query analytics tool and see what query is being passed, and then tune that query appropriately. Or if there's write latency, you can kind of figure that out as well. And then you can kind of also see your query efficiency detail, which in my case, because I don't have any indexes, my queries are not even showing up as being efficient, which is correct. Operations counter details, that's going to tell you again who's running the most commands, who's doing more get mores, which is returning back to the database to get more data, who's running lots of deletes or inserts or updates or just queries in general. And then document operations, again, these are ones that are going without indexes, so that can be very helpful to see who's doing most of those. So that's the MongoDB instances overview dashboard. There are some other MongoDB ones as well. There's a MongoDB instance summary. So this is kind of another way of looking at a lot of the same data from that last dashboard. So here we can see what commands were running at a specific time. Again, pretty slow system, so time to live delete from some MongoDB internal collections was it. Latency detail, what kind of queries were latent? Was it my reads and my writes, or in this case, just regular command queries? Let me change the view on this so the data looks a bit more interesting. You can see connections over time. This can, again, be helpful for seeing any kind of connection spikes, and then you can kind of drill into that. Number of cursors are also helpful. Document operations. So what were the documents doing, or sorry, what were the operations doing during this time interval? Were they inserting records or returning records, updating or deleted? Queued operations would be how many of your operations were queued, whether they were writes or reads. Query efficiency. These yellow spikes are probably MongoDB internal ones, and these green ones were some things that I've been running, which are not very efficient. Or sorry, not as efficient, because you can see they kind of dip to 0, and they'll spike up and then dip back to 0. Scanned and moved objects, you can kind of see here. How many documents were scanned or moved during that, and then some get list error, how long they would take. I didn't have any, obviously, and then any page faults or asserts, and then node summary. This would show kind of the equivalent OS metrics. This will give me like what my memory and my CPU and that type of stuff is while I'm running this. So the last 3 dashboards are for 3 different storage engines that we support for MongoDB. mmap v1, which is the legacy one. MongoDB in memory, which as the name suggests, is the in-memory MongoDB storage engine based off of WiredTiger, and then the WiredTiger one itself. So these are going to give you storage engine specific metrics. In my case, I'm using a WiredTiger storage engine, so let's hop into that one. All right, so here we can see how much of my WiredTiger, about a little over 100 megabytes out of 1.3 gigabytes for my overall WiredTiger cache. How many WiredTiger transactions we have, whether they're committed or rolled back. The cache activity, how much data is being written into or written from or read into the WiredTiger cache. How many blocks have been written or read for WiredTiger. How many sessions WiredTiger has. And then next, we've got WiredTiger concurrency tickets. If you're not familiar with WiredTiger, it uses a concurrency ticket system, but where if you use the default settings, you can only have 128 reads and 128 writes concurrently happening at a single point of time. Once those concurrency tickets get exhausted, you'll see things start to queue up here in the queued operations. So this can help you identify if that's happening. Oftentimes, if you have poor performing queries that run longer, but kind of stack up and kind of hold on to those tickets longer than they should, then you'll start seeing queuing happening on this side, whether it be for writes or reads. Checkpoint time. WiredTiger uses a checkpointing system to make sure that data gets flushed to disk from its cache. You can kind of see here with the cache eviction, when data gets evicted from the cache. And then this graph with WiredTiger cache capacity, you can see how much of your WiredTiger cache you're using. This is very helpful. If your WiredTiger cache is full and you see very high cache eviction, then this can be helpful in knowing that you're going to need to tune your WiredTiger cache and likely increase the size. Potentially also increasing the size of whatever instance you're running it on. And then WiredTiger cache pages, you have your total amount of pages and then how many of them are dirty, which is just another term for have not been written to disk yet. If you see this dirty number kind of being really high, that can indicate that your checkpoints might be going too slow or you're writing data too fast for MongoDB to be able to catch up. Then you should potentially look at tuning your WiredTiger checkpoints or your WiredTiger cache. WiredTiger log operations and log activity and log records are just different ways to kind of see what WiredTiger is doing. Again, this can point to different bottlenecks if you're reading or writing too much data. Document changes are going to show you how much you've inserted or data that you've gotten returned or updated or deleted. And scanned and moved objects is similar to on the other screen. Again, if you see lots of objects being scanned, that can very quickly point to an inefficient query or lots of queries that are doing lots of reads. So, and that becomes even more problematic in a sharded cluster environment. Then you've got your MongoDB summary, which is again is just the high level from your instance summary with some of the basic stuff here. And the node summary is just similarly a high level OS metrics for your CPU utilization, your memory usage, and all that. So all these cool dashboards and great metrics are how you can optimize and troubleshoot your MongoDB instance deployment. So with that, I will say thank you for listening. You can find me at, again, on Twitter. There's my Percona email, and on LinkedIn. I'm happy to answer any questions you might have on PMM and MongoDB. And until then, have a great rest of your conference. If you're interested in PMM, there are 2 other talks, one covering MySQL and one covering Postgres with PMM. I encourage you to check those out as well. Thanks, and enjoy the rest of your conference.